Hello, in the last video of this series, we talked about how distributed systems leverage load balancer to distribute the incoming traffic among the nodes. So in this video, we'll be going to talk in detail about the load balancer and the different techniques used by load balancer to distribute the incoming traffic. So let's have a look at what actually is a load balancer. So a load balancer is basically a network or software application that distributes the incoming traffic among the servers to provide high availability, efficiency, and utilization of server and to maintain the system at a high performance level. So we have several load balancing algorithms. So let's start discussing about them. So there are basically two types of load balancing algorithm. First is the static load balancing algorithm and there is dynamic load balancing algorithms. So in static load balancing algorithm, the user can predetermine which node the request will be directed to, while in the dynamic load balancing algorithm, the redirection of a request is entirely dependent on the current status like current load, capacity, etc. So the first algorithm under static load balancing is round robin algorithm. So round robin algorithm is a pretty straightforward one. Requests are distributed across the servers in a sequential or rotational manner. So if we have request 1 coming first, so it will go to service A, request 2 will go to service B, request 3 to service C, and then it rotates back to service A. So this is the round robin algorithm and it is very easy to implement, but it doesn't consider the load already on the node the request is redirected to. So this is not a very efficient algorithm to consider when looking for a load balancing algorithm. Now let's talk about weighted round robin algorithm. In weighted round robin algorithm, what we do is we assign weights to each of the servers, which basically signifies their capacity. Say for example, here in service A, the weight is 3. That means service A has higher capacity compared to service B and service B has higher capacity compared to service C. So more requests will be redirected to service A, then B, then C in the increasing order. It is useful as we take into account the capacity of the servers and the load is distributed accordingly. Third and the last algorithm that we have in static load balancing is the hash IP. So this algorithm basically calculates the hash of the incoming IP request. These are useful when we have a sticky session or we want request coming from one system to be redirected to the same node for each of the requests. So source IP hash is a load balancing algorithm method used in network load balancing to distribute incoming requests among a set of servers based on the hash value of source IP address, and this aims to ensure that the request originating from one IP address always gets redirected to the same server. It is ideal for applications needing sticky sessions like banking applications and some of the stock market or financial app. Moving on to the dynamic load balancing algorithm. So first one in the dynamic load balancing algorithm, as we talked, dynamic load balancing algorithm decides which request will be redirected to which particular node or server depending on the current scenario or current load on the server. So least connection method basically determines which server has the least number of active connections. It is ideal to distribute incoming workloads in a way that minimizes the current load on each server, aiming for a balanced distributed system. Ultimately, that is the goal of a distributed system design. It is ideal for applications where some requests take longer than the other. So some servers might be occupied for more time than the others, in which case the other incoming requests can be redirected to the other available servers. It is useful when some connections stay live longer. Living longer than usual means that the response time is very high or the computation involved in that request is very high. It ensures that the new requests go to the servers with fewer active connections. This kind of algorithm is great for fluctuating traffic, in which case we don't know, it is not predetermined that we will have the same amount of traffic throughout the day. So it is a dynamic algorithm, depends on the number of active requests or active connections to a server, and so we write a piece of code that determines which server our request will be redirected to. So moving on to the least response time method. So least response time method basically depends on the historical time taken by the servers to respond to a request, and it does not incorporate the kind of request, because some kinds of request might take longer than usual to process. So say for example we have server 1, server 2 and server 3. In this case, incoming requests, so our load balancer will always keep a track of the response time of each of these servers. Like maybe we can use average of the time that they take for request, and then calculate the response time of these three servers. Depending on that, the incoming request will be redirected to the server with least response time. So it considers historical performance and makes decision about where to route the incoming request, optimizing for the faster processing. The dynamic aspect of this comes from the continuous monitoring of server and the response time of theirs. And this algorithm is adaptive in a way that when there is more load on a server, the response time will automatically go down. Hence, the load balancer will know that we don't need to redirect the request to the server that is already overloaded and having low response time, rather than that we can use a server which is idle and having a high response time. But there is a drawback of this approach. It only considers historical data, and historical data does not contain the information about incoming request, whether it was a high demand request, high compute request, or was it just a normal one. The next and the last one in the dynamic load balancing algorithm is resource-based method. So the resource-based load balancing algorithm distributes the incoming traffic depending on the CPU, memory, and network bandwidth. These are the few parameters by which a server is basically ranked in terms of their capacity. So the incoming request basically goes to the one that is having higher capacity, in short, and this is useful for applications requiring very high CPU intensive or memory intensive tasks, and these work well when server have different resource levels, as the algorithm adapts to each of the server's real-time capacity. So this not only includes only the total amount of compute or memory that a server has, it also incorporates the current available memory and CPU and network bandwidth that a particular server holds. So in that way, it is dynamic, that it determines the redirection of incoming request depending on the existing or available capacity of a particular server. So that's all for today's video. Let's catch up in the next one discussing about another exciting system design topic. Thank you.